and welcome to section 3.2, visualizing data and doing exploratory data analysis. We're going to be looking at best practice, some Python examples and tools and libraries that are relevant to data visualization. What is it? Well, data visualization is essentially illustrating data in charts, plots, and graphs, and this could even be animated visualizations. This helps communicate complex patterns and relationships to audiences. It makes meaningful insights that you've extracted from the data immediately visible that might not be so readily consumable and visible or understandable if you show it in tabular form. It becomes easier to promote shared understanding across the organization for a variety of audiences. And data visualization forms a big part of business intelligence dashboards as well. There are a number of tools available. Starting from the bottom left, we have Click, which is a proprietary data visualization and business intelligence suite. Some contemporaries include Power BI and Tableau. Power BI is the Microsoft suite. And these three tools provide business intelligence dashboards and the development of these dashboards, connecting it to databases or Excel files or CSVs, updating the business on various business processes and details. Then we have some other libraries that may or may not be open source, in this case chart.js, Looker, which is part of Google Cloud, we have Bouquet, Folium, Plotly, Seaborn, Matplotlib, and NetworkX, which are a number of libraries that you can use for visualization if you're using Python, for instance, and then D3.js as well. So the best practice in terms of data visualizing or data visualization is to first choose the right kind of visual. You have to match the type of the chart or plot for the data that you have at hand and the message that you want to convey in line with the audience that you're talking to as well. You must keep it simple. Avoid cluttering and adding too much noise or too many points in this visual. You have to keep a focus on clarity and simplicity. You do this so that you can really narrow down on the point or the central idea that you want to convey. Use color wisely so you can highlight important data, but if you use too many, then it can also become quite cluttered and confusing. Label properly so that your axes and your legends and your data points are all clear, and always tell a story which has a starting and an ending. Use the visuals to create that narrative and work on that flow of the story that guides the audience through the data to bring home that point that you want to leave with the audience. And we'll see more about this in detail in one of the sections later on in this unit that focus on developing a data story and narrative. We looked at things that we should do in best practice. Now just quickly looking at what should be avoided. We should avoid overcomplicating things. If we use too many types of charts or excessive number of data points, then sometimes we can lose the central idea amongst it all. Always make sure that your axes and your scales are aligned and mapped and normalized so that you can avoid misleading impressions, especially when you're using multiple plots stacked together. If they all have different scales, then perhaps the audience will not be able to spot this at a glance, and they might get some kind of a misleading or inaccurate impression about the narrative that you're building with the visualization. And finally, avoid ignoring the audience. You have to always adapt the visuals and the illustrations of the data to the knowledge level and interests of your audience. So some examples, very much commonly used bar plots and line plots and scatter plots, box plots and violin plots are some other graphs that are used to illustrate distributions. So let's look at it one by one. We're using examples here from the Seaborn gallery. Seaborn is an open source library used in Python together with pandas within the Anaconda stack. So in this case, we're seeing the Antarctic penguins data. Here we see the body mass in grams of these three species. And these are faceted or divided by gender, so we can see male and female in different colors. Here's an example of a line plot. All of these examples are from Seaborn. we're seeing flight data, the number of passengers on commercial airline flight carriers from before 1950, when commercial flights started, up until 1960. The y-axis is showing the number of passengers, I believe, and each line represents a month. In the summer months, a lot of people, more people tend to travel, therefore we see those blue lines slightly higher. This is more concisely and simply depicted by this line plot, which is showing the mean, which is this central blue line, and we can see that in 1960 the spread is a lot bigger compared to the spread in 1948. Now we look at a histogram. This is back to the penguins data. We're looking at flipper length in millimeters, and we're looking at the count of each of those data points for on the y-axis. The three colors represent three species of the penguins, and we can see that this is a bimodal distribution, and we're seeing a peak around 195 and another peak that is around 215, and there's a mix of all three species around 215 millimeters, as we can see the blue, brown and green colors here, 210, 215 millimeters. So this essentially shows a stacked view of or an overlaid view of the three species histogram. Here we are looking at a scatter plot. There's four groups, A, B, C, and D. The data has been captured from 2000 to 2008, and we don't know what the y-axis is, but we can see some separation that's happening alongside this feature as well, especially for data that is captured after 2004 or 2003, around 2003, mid 2003. Before that, the three or four groups or clusters tended to be mixed with a general trend that was on the up, and then we saw separation from 2003-4 onwards in almost all of the clusters, with some mixing happening around this region. And then we look at box plot. Here we have data from the ship Titanic. On the y-axis we have age of the person, the passenger. On the x-axis we have first class, second class and third class, the different compartments in the ship. And the boxes here are showing the distribution, so you can see that the spread here is a lot larger. We can see here that the age goes right from infancy up to about 70, and these are whiskers, so we can see essentially between the 25th percentile and the 75th percentile, with the median here, the median between 40 and 50, around 45 years of age. So the 25th percentile is just above 30, and the 75th percentile is around 55 years of age. In this case, when you look at those who made it out of this disastrous event alive, were quite young as well, infancy up to about 65 or 64 years of age. But the majority of them, between the 25th and the 75th percentile, were 25 to about 45 years of age that made it out alive from the first class. Comparing this to the second and third class, we can straight away see there are some outliers that haven't even made it to the whiskers. They're shown as outliers. It also shows that the age is decreasing as the classes change. So second class shifts a lot lower than first, and then the third is even further down. At the same time, we can also see some comparison of deaths as well. So those who made out alive were a lot younger than those who, or at least somewhat younger than those who didn't, in all three classes. The same thing can be viewed in a violin plot. So the distributions are slightly changed in the way they are illustrated, but you have the same thing in this case. Those who were alive are brown as well, and those who didn't make out alive are shown in blue. First, second and third class, and age on the y-axis. We can see the same data illustrated in a different manner, which actually allows us to appreciate the distributions a bit more clearly, because in this case you can see that the second and third class have this high peak. So the mean was around the 20 or early 20 years of age in third class, mid 20s in the second, and around 45 in the case of the first class. Also, the distribution is a lot flatter when it came to those who died in the first class, and they're not so flat. They're quite peaky in the second and third. Similarly, those who made out alive, somewhat flatter compared to the bimodal distributions that we see for those who made out in one piece in the second and third classes. Some more examples: joint plots and cluster maps. So joint plots allow us to see two features or attributes against each other. In this case, we go back to the penguin data, bill length in millimeters and bill depth, the three species, and not only can we see the scatter plot and color coded by clusters or by species, but we can also see their marginal distributions as well. In this case, the scatter plots are replaced by a contour plot, so we can see the surface of the distribution for the three clusters and the overlap as well. Also, we can do different types of joint plots in Seaborn. Then we can also do heat maps and cluster maps. So in this case, we can see another data set showing some correlation between models and tasks. And on the right hand side, you can see the same thing as represented here without those correlation constants. So let's take a first example, and we'll focus on Python in our course. So we'll take a Python example. We will be using the libraries that we've mentioned, and we will see a bit more about this in a moment as well. The matplotlib pyplot library, and that's freely available with the Anaconda distribution as well. So in Python, we do the import statement to import this foundation library. For visualization, we give it an alias to say import matplotlib.pyplot as plt, so we can easily use in our code, just refer to this as plt instead of writing all of this. We import Seaborn, another library that we've seen before with all of the examples, and momentarily we'll look at it a bit more in detail as well. We give it an alias SNS, and we import pandas as pd. Pandas is another foundation library for data manipulation and reprocessing. It allows us to organize data in data frames and process it and apply different types of functions to it. We can feed it to the foundation libraries for visualization and modeling as well with machine learning. So it really is quite a handy library. Let's say that we have a sample data. We create a pandas data frame. We give a variable, call out the variable, and assign pd.data frame to it. Data frame function or constructor function has a requirement that we need to give it a dictionary in this case, which is giving two elements, category and value. Both are arrays with some values, ABCD 10, 20, 15, 30. We want to put this in a bar chart with matplotlib. So we call pyplot from matplotlib and then figure, give it some figure size, and then call the bar plot function from pyplot as well, giving it the data for x-axis and y-axis, give it some color, label the x and the y axes with category and value, and give a title to the bar chart example as well. To show this graph, we use plt.show, pyplot.show, and it illustrates that plot. You can do the same in Seaborn, and instead of showing it as a bar plot, we can plot it as a scatter plot, where you do the same, create a new figure with pyplot plt.figure, give it some size, which is not necessary, but it allows you to make it more uniform and consistent, aesthetically pleasing. Seaborn.scatterplot, which in this case is SNS because we gave it that alias. Give it the x-axis and the y-axis values, category and value, which is in the data pd.data frame, the pandas data frame that is in the variable data. We want it to color in red and give it a size 100 for the markers. And we again label the x and y axes, give a title, and show the plot. So there are endless possibilities, so many libraries and tools out there. You can choose proprietary tools, open source tools, and the idea is not to really get bogged down under all of this choice and all of these options. The focus should be to make the best illustration that is adapted to the type of data that you have, that brings out those insights and meaningful information that you want to convey to the audience, and all sorts of such considerations. And therefore, I would advise you to be agnostic. I always go for the library that provides the best option, the best interactive visualization, perhaps in an animated manner, or some options that you can select on the fly to change the illustration to be able to analyze it a bit better. Examples like Plotly allows you to have more interactive visualizations, as we'll see momentarily. And there are varied illustrations. You can use different types of illustration. You can first and foremost color coded. You can create some kind of rules like you do in Excel. Anything below 0 is red and anything above is green, for instance. You can show linear patterns in such visualizations. You can create business charts. You can create more complex technical plots, and this all depends on what libraries and tools you're using. You can animate the data. You can create time series illustrations or dimensionality reduction if you have several attributes that you want to show it on 2 or 3 dimensional illustration or visualization. But in this case, as I said, we limit ourselves for this course to Python-based visualization libraries, and we'll review some of them, the more important ones that we will need to learn and use in our daily work. First and foremost, as I've already introduced you, matplotlib, and second of all, Seaborn. Both of these have been mentioned just now. We've looked at some sample code as well. Matplotlib is the most popular and widely established plotting library. It's free and open source. It's an alternative for MATLAB. It's usable in scripts, Python scripts, Shell, Jupyter notebooks, and so on. Seaborn is based on matplotlib. It's open source as well. It has some really sophisticated internal functioning, which automates a lot of the work that we need to do in slicing and dicing, so it really helps and speeds up things, and is aesthetically pleasing as well, with very rich plots. The list of plots is very similar to matplotlib, including bar, line, pie charts, histograms, scatter plots, box plots, violin plots, etc., as we saw. Plotly is the third visualization library that I also mentioned briefly just now. It's also open source. This is based on plotly.javascript. We can create HTML files with this. We can create web-based data visualizations in Jupyter or web apps using Dash. The output that it provides is quite similar in terms of illustrations to the previously mentioned two libraries, Seaborn and Matplotlib. So here's a look at the Matplotlib gallery. It's from the website, and this is only an excerpt. There's a lot more on there. You can follow the link on the screen and look at these yourself. A lot of options there in terms of classical, bar plots, scatter plots, line plots, but also quite sophisticated ones that you can explore on your own. A look at Seaborn gallery as well. So many different options that we can see. This is a bit more comprehensive view because of the manner in which the gallery is presented. We can see here that there's a lot of options that we can get. So let's pause here and take another Python example from Seaborn. This time we'll look at histogram. So we import Seaborn as SNS. We import matplotlib. PyPlot as PLT, the same way as we did in the previous example. We take the iris dataset, which is a dataset that is quite heavily used in data science exercises and examples. In this case, it's giving us some data about flowers, the iris flower, the sepal length, the different species, etc. So we'll create a distribution plot by creating a plt.figure, again a new figure which is being given a figure size to be consistent, seaborn.histplot function which draws a histogram, giving it the data frame that we've created with the load dataset. This is the Seaborn function as well, which it just loads that dataset straight away and creates a data frame in pandas for it, which is stored in data. Coming back to histplot, so we look at the two attributes, which are essentially sepal length that we put on the x-axis. The y-axis, of course, is going to be a count of those because it's a distribution plot, a histogram. And we give it a color using hue, so hue is going to be focused on the species, and it'll divide or differentiate the histograms based on species. It will be stacked on top of each other with the multiple keyword that's got stack, the multiple argument that's got the keyword stack. And we give it some palette, which is a palette of colors, pastel in this case. Label the x and y axis, sepal length and frequency, and distribution of sepal length by species. Now, we mentioned Plotly as well. So looking at Plotly gallery, again, this is just an excerpt. There's plenty more charts that it allows, and these are interactive graphs, so it's quite handy. And so let's look at an example with Plotly. We import Plotly in Python script .plotly.express as px. We import pandas as pd, so we can create a data frame. We do the same kind of category value. In this case, we add another attribute, which is size, and this is what we have as a data frame. We put it inside an interactive scatter plot by calling px.scatter, so plotly.express.scatter, which is a scatter plot. Put it inside a figure called figure.show. How do we feed the data in? We specify the x-axis as category, y as value. The size for each marker will be depicted by this size attribute. Color is going to be based on category, so it'll give automatically a sequence of colors depending on how many points there are, or how many categories there are rather. Since this is an introductory course, I don't want to go too deep into each of these, but we'll do a quick overview and then see some examples of Folium and NetworkX before closing this lecture. Bouquet is an interactive library as well, much like Plotly. Is web-based as well, can be used in interactive web apps, HTML, JSON. Allows tiered control so that if someone is new to this, they can really call simple function calls, and only one call will create a graph or a plot. Or if you're an expert and you want full control, then you can really go deep down into the nitty-gritty of things and construct the graph yourself with more control. Geoplotlib is a Python library that is used to create geographical maps, and it allows various types of maps. On the right hand side you can actually see some examples. So you can see there is a New York State population demographics that's being visualized, Melbourne primary schools, even Napoleon's march on Moscow in the 19th century, which is being visualized starting in Europe and Western Europe, moving into Russia and then returning. It's quite a popular graph that's depicted using the Sankey diagram. This diagram is usually employed when we have to do path analysis. And then you have cartogram of US states by obesity rate, and point plot of US cities, etc., by population. So it's quite a handy library as well if you have geomaps to visualize. ggplot is originally an R package. It gives the same kind of list of visualizations. You can add multiple layers in a single plot, and of course the same goes here. If you want to automate things, that it comes at the cost of less control. And then we have Folium and NetworkX as well. So let's look at examples for Bouquet, and then we'll move to Folium and NetworkX. So Bouquet is again quite rich, and it provides a lot of options. Actually, this is one stop visualization library where you can do a lot of things, and even in this excerpt you can see that you can do different types of visualizations, even geographical maps as well, heat maps. You can do networks as well. So it really is quite rich, and it provides almost every type of visualization that you can think of. Folium is more specific to maps, and it's quite detailed, and you can create interactive visualizations with it. Allows a lot of control. In this case, we're creating a map and adding markers with this example from the Folium website, which is pythonvisualization.github.io Folium. So just a basic example of creating a Folium map by giving it some latitude, longitude values for the location, which is in Canada, Vancouver here. And then you can use this in a Jupyter notebook and display it. You can also add markers to it, which in this case is adding these two markers here, creating a Folium map with these two specified lat long for the location, a zoom start value so that it's zoomed out or in at the right resolution, and adding Folium.marker twice with the location, the tooltip. So when you hover over it, it'll give you some kind of a tooltip, the pop-up, and the icon that should be used, in this case the icon of the cloud. And then you add it to the map, which is stored in M, and that's how you add the marker. So NetworkX is a bit different because it's a visualization library that is solely focused on networks and topologies. In this case, we see two examples, the one on the left, and both of these are from the NetworkX website with the links that are given. You can look at the website for more details. On the left-hand side is capturing World Chess Championship games from 1886 to 1985, almost 100 years, exactly 100 years. And you can see that in this case, the edge width is the number of games played, and each of the node is a player. And the node size is the number of games won. So we can straight away start to see that Mikhail Botvinnik is clearly has won more number of games than any of the other big winners. And you can start to see who they played against more as well, because the edge width is the number of games played between those two players. So this is quite a good way of visualizing and looking at relationships, entity relationships, etc. On the right hand side, again, we see another visualization, which is plotting LANL routes. So you can start to see some really nice visualizations that start to form. I would advise you to be tool agnostic and solution oriented. And like in modeling and developing data solutions, even with the data visualization, the same approach applies. There are so many options out there, both in terms of the type of charts and the tools and libraries that are available to be used to create those charts. Each of these has its merits and advantages, especially when you really look at it from the context of the problem and the data set that you have, that you're trying to work with and trying to visualize the problem that you're trying to solve and the solution you're trying to build. So let's say if you have a geographical data set, you want to put it on a map, you need interaction, then you might decide to use Folium or you might decide to use Bouquet, depending on what interaction and what kind of functionality you're after. Or if you have a graph or network topology, then you can maybe decide to use network X, or again you might just have a very simple requirement that Bouquet might be able to facilitate you with. So before we end this lecture in the second section of Unit 3, there are plenty of data visualization courses on the web that would help you to get to grips with this, and you can play with examples and run some of the exercises. So there are a few links on the screen that you can see, some data visualization courses available on Coursera, quite good ones. Harvard Data Science Visualization course, Introduction to Data Analysis and Visualization in Python, that's on Simplilearn, and then IBM Data Visualization with Python as well, that's again on Coursera. Thank you for joining me, and I hope you enjoyed this lecture. I'll see you in the next one.